General term of a number sequence. What is this, guys? What's a general term? General term, to be very simple, is just the rule of any sequence. So this rule gives us the ability to find whatever term. So if you want like the 10th term, you can just use that general term. If you want the 100th term, you can also simply find it by putting it into the general term. So it's like a rule that simplifies everything for us. So you can see here we've got 3, 5, 7, 9, and it continues on. We know that first term is 3, T1. T1 is basically meaning term 1, so the first term. So remember that notation there. The first term is 3, which is 1 plus 2, isn't it? It's 1 plus 2. I'll show you why I wrote it like that. And 2 is 2 times 1. And again, I'll show you why I wrote it like that in a minute. So 1 plus 2 times 1 is simply 1 plus 2, which gives us 3. We can go the other way around to make it a bit more simple for you guys. I'll show you why I wrote it like that, because now you look at the next term, term 2, second term, which is 5. That is 1 plus 2 plus 2. So it's kind of similar to this previous one, but I added an extra 2. Now 2 lots of 2's mean we're multiplying 2 by 2, isn't it? 2 lots of 2's is 2 times 2. So 1 plus 2 times 2 will come back to our 5. Now, just keep watching. I'm going to look at term 3, the third term, which is 1 plus 2 plus 2 plus, and another 2. Can you see that? So it's kind of same as the second term, but we've added an extra 2. So to get the third term, I add 3 lots of 2's. To get the second term, I add 2 lots of 2's. And to get the first term, I add just 1 lot of 2 to 1. So we have 3 lots of 2's here, which means it's 2 times 3. So can you kind of see the pattern now, guys? You can see that to 1, we're adding how many lots of 2's we want. So again, let's try another one. Term 4, which is 9. You guys can probably imagine what it is now. It's 1 plus 2 plus 2 plus 2 plus 2. So 4 lots of 2's, which means it's 1 plus 2 times 4. So we're adding 4 lots of 2's, and it kind of makes sense. 1 lot of 2 we're adding, 2 lots of 2 we're adding, 3 lots of 2 we're adding, and 4 lots of 2's we're adding. So I'm assuming you guys know how to do next. Term 5, we'll have to add 5 lots of 2's to 1. So that's the pattern, guys. I'm going to write a little general rule for this. So whatever nth term we want to look at, so I'm going to write it as Tn. So, I mean, n could be 10, n could be 50, n could be anything. Whatever term we want, we don't know, we'll just write n. So whatever term, Tn is 1 plus. So see how the pattern was just adding from 1? So 1 plus 2 times as many numbers as what n is. Okay, guys? So see, if it's third term, we add it 3 times. That's what the rule is. That's called the general term. So, and you can write like this as well, like in a little parentheses like that, in these little squirrely brackets, that also kind of expresses the general term. So, this is how we do it. But the next few questions, I'm going to actually give you what the general term is, and it's your turn to try and find what those particular values are. So, I'll show you. We'll go straight to question 1. Tn equals to 2n plus 3. So, this is a general term. This is a rule, or specifically the general term of a particular sequence. And see how it says Tn? So it gives us the nth term. So if you want the 50th term, you'd sub in 50. If you want the 100th term, you'd 700. You'd get it straight through that general term. So for question 1, it says find T4, which means find the 4th term, which means n. See how the n is replaced with 4? You replace this n with 4 as well. So 2 times 4 plus 3. 2 times 4 is 8. Plus 3 is 11. So that is the 4th term, which is this T4 here. Now I want to find T10. As simple as doing this one as well. Just sub in 10 into your n. So T10 is 2 times 10 plus 3. 2 times 10 is 20, plus 3 just simply gives us 23. That will be the 10th term of this general term, of the sequence. Make sense, guys? Question 2. Again, they give us a general term of some particular sequence. Tn is 2 to the power of n. So if I want to find T3, the third term, simply sub n as 3. So 2 to the power of 3, which gives us 8, is the third term of the sequence. Now B, T5, which means the 5th term. I want to find the 5th term of the sequence, replace the n with 5. So it's 2 to the power of 5, which is going to be 32. That's the 5th term of the sequence. As simple as that. So you just need to basically substitute it into our general term, and you'll get whatever term you want. We'll try another one, question 3. Tn is negative 1 to the power of n. Negative 1 to the power of n, so it's the whole thing to the power of n. So when I ask you to find T3, just sub in n equals to 3, so it's negative 1 to the power of 3. Negative 1 to the power of 3 is negative 1 times negative 1 times negative 1, which comes back to just negative 1. So a negative number, when the power is an odd number, it comes back to negative. Just remember that for me. So then in part B, when they ask you to find T4, it will be negative 1 to the power of 4. Now, when the power is even, guys, the outcome will also be positive, will stay as positive. An even power makes the outcome positive. So negative 1 to the power of 4 is positive 1. It's negative 1 times negative 1 times negative 1 times negative 1, which you know that it's going to be positive 1. So that is what the general term gives us.